Morning, my beautiful humans, beautiful souls, beautiful listeners. Welcome and thank you for being on this podcast, Beyond Via Space. And I'm your hoster, Julie. I'm truly excited for today's episode because I have invited my dear friend, Phil Metzger. He is a planetary scientist at the University of Central Florida. I got to know him since 2019, and I know he was working on various projects on asteroids, on technology, as well as on the moon. But by the time I was doing research, his background, I was truly impressed that his long credentials. He has worked on different programs like KSC Swamp with Kennedy Space Center. He has worked on solar system exploration, rocket exhaustion, interacts with terrestrial soil, the mechanics of soil, and characterizing lunar and Martian soil. But he also on the lunar and the Mars architecture team and worked on lunar exploration. And he's currently working on developing strategies to move the industry off the Earth and into the space. The list can go on and on and on, and he received the Asteroid Silver Snoopy Award in 2010 and was selected as Canada Space Center NASA Scientist of the Year for 2011. I'm very excited, not just because Dr. Phil Metzger's capability and knowledge in the world of space and the various areas he has covered, but he is also a renowned speaker, and literally in my eyes, he is the world ambassador for the space and the space technology. His ability of translate these deep, complex technology into a simple, more understanding concept for normal people like us. It is just incredible and phenomenal. And I know we're going to have a great time. So let's welcome our guest today, Dr. Phil Metzger. Dr. Phil, so good to have you. And I just recall that we got to know each other since 2019, really.
Yes,
I mean,
we had a few discussions about space mining and about the business of space.
At the time, I was still very much in the commodity trading, and whatever you told me at that time was seems so far away. And now, fast forward, we are 2023. It seems everything is just a lot more, a lot more touchable, a lot more realistic. A lot has happened for that way.
Well, it's an exciting time in space. There's a lot happening and a lot to talk about.
Yes. And before we dive into, actually, I was just fascinated because although I got to know you in 2019, but until doing these podcasts, and I started to research a bit of your background. It's fascinating that what you have actually done, the various topic you have covered, literally. So you are a planetary physicist, but you have worked with NASA's Kennedy Space Center, and you have worked on a solar system exploration and rocket blast effect. Yeah, and you worked on various architecture for Luna, for Mars, and the list can go on and on and on. And it's just amazing. I don't know how you actually get to where you are and have done so many different research themes. I think the listener would be just really curious to hear that as well. If you could just walk through a bit our background.
Yeah. So it's been a very long and interesting career. I'm definitely doing things that I never imagined I would do when I was starting out. I started working on the space shuttle. I was on the launch team, and I worked on the navigation and the communication systems on the space shuttle. And then from there, I switched over to the International Space Station. And again, I was working on the communication systems. So I was testing it and helping put things together to get ready to go up into space, troubleshooting, finding out what was wrong, finding out what changes we had to make before launch. But eventually, I started wanting to work on planetary exploration, like working on technologies that are going to go to the surface of the moon or to the surface of Mars or asteroids. And right about that time, NASA offered a fellowship program for employees to go back to school and get a doctorate. And so I wrote an application and I said, I would like to go back to school and I would like to study how rocket exhaust blows soil during lunar and Martian landings. And the managers at NASA selected my proposal, and I got to go back to school. I got a master's degree and a doctorate in physics. And I did research on the physics of granular materials, because the surfaces of planets are granular materials. You know, they're pebbles and grains of sand and rocks. And so I studied the physics, the mechanical behaviors of these materials so that I could learn how to create technologies that interact with those surfaces of planetary bodies. And then I became a part of a team in NASA working on how to extract resources from the moon and Mars and how to do construction on those planets. And I was specifically working on figuring out how to build landing pads and how to stop the blast of soil and rocks. When you land on the moon or land on Mars, you blow sand and rocks everywhere. So I was leading that effort inside NASA for a long, long time, and we made a lot of progress. I got to do a lot of fun things. I got to fly in the reduced gravity airplane. So I've done about 450 parabolas of reduced gravity as part of several flight teams. I got to do tests on a volcano, testing robots to study how to work on the moon, and many, many other things. And I had no idea that this is where the career would take me, but it's been very exciting. About 8.5 years ago, I left NASA in order to take a faculty position at the University of Central Florida. And I'm still working on these same technologies, but I'm doing it as a university researcher at this time.
Wow, just listen to all your experience on, microgravity, plane and the testing center and, volcano. Wow, that's pretty much everybody's dream to, I'm sure the condition might be quite extreme. It just, what are you guys trying to explore? And then actually is really at the frontier of the technology and doing all these cool things. Yeah, that sounds really cool for me. Yeah,
I co-founded a group of laboratories at NASA. We called these laboratories the Swamp Works. And it was just me and some other people who wanted to work on cool stuff. And so we found a way to make it happen. We were like entrepreneurs, but inside NASA. So intrapreneurs. And we created this laboratory to develop these technologies for planetary surfaces. And it was all just because we thought it was cool. We wanted to do cool stuff. And so I'm glad we did.
Oh, that sounds so great. Entrepreneurs. That's brilliant. And so the science doesn't have to be dry. It could be extremely fun, right? So that's good to know.
Yeah.
Okay. Well, before we dive into the topic, which we're going to be really zooming a lot about the moon and the moon economics. Before that, I would like to just for the listener to hear from your perspective about why we have to go to space, why we have to go to moon. You know, a lot of people thinking there's still a lot of resource on Earth, and why we spend the time, money, effort into space. And, you know, just would love to hear that from you.
Yeah, so those are good questions. I don't think we're going to run out of resources on Earth because we can always recycle resources, you know. But the problem is that we've been using up the best resources, and so it's becoming more and more expensive to get the lower grade resources and to recycle. I mean, we don't recycle very much because it costs so much energy. And so if we were going to recycle everything at the current state of technology, it might actually make the world worse, because the increase in the supply chain to support all the extra energy generation and all the extra machinery required to do all that recycling would itself be another burden on the planet. And so I think the main reason we want to develop industry outside of our Earth is to protect the Earth. It's not because we need those resources. It's because getting the resources off the planet is better for the planet. It causes less of an impact on the ecosystems. And there's also, of course, economic benefits, because as we get better robotics and as we get cheaper access into space, some of these resources in space become competitive. And so if we were not going to go get them, we would actually be penalizing ourselves. So it's a combination of what's becoming possible, what is becoming economic, and also it's the right thing to do for our planet. One other point, though, is that once we can develop a supply chain to mine and manufacture anything off of the Earth, that will give human civilization access to literally billions of times greater resources than we could ever access on the Earth. And so this gives us the potential to scale up our industry. And that means we will be able to do much greater things as a people. We will be able to do greater science, greater exploration. We can help improve the condition of all humans. And so being able to scale up our supply chain, 1,000 times, 1,000,000 times greater than what we have on the Earth is super inspiring. It creates a picture that helps young people become enthusiastic, and it motivates them to pursue education. And so the optimism of this open-ended worldview is a motivator right now to help make the world a better place.
I love it. Open-ended worldview. But you have touched so many topics that it's raised like a zillion questions that I want to ask. Okay. But the key takeaway is actually, there's quite a lot of talk with thinking about we actually going to running out these resources. But, obviously we haven't even starting to look into seriously deep sea mining. So I actually tend to agree with you. They're probably enough. But like what you said, the best resources are being taken away, and the entire world are talking about zero carbon, zero carbon economy, green energy, and how exactly we're going to achieve that if we just focus on the traditional mining process, right? So I really think that's very, very fascinating. And you touched also regarding it's going to open a new world of economics. There's also a lot of economics reward, and is a heavily debated topic, which we're going to touch a bit later. And there's another classic question I would like to ask is, what is space mining? Just for the audience to get answer from the planetary scientist.
Okay, well, space mining, we could define it very broadly. It means obtaining resources outside of planet Earth. So it could mean going to the moon and getting material resources off the surface of the moon. It could mean Mars. It could mean asteroids. If we wanted to be very broad and expansive, we could say it even includes getting solar energy in space, or accessing the vacuum of space as a resource. So there's a very Zen approach. It's like the absence of everything is a resource, because it's hard to get really good vacuums here on the Earth, but in space it's really easy. And there are a lot of industrial processes that want vacuum. So very broadly, it could mean getting any resource outside of planet Earth. But more specifically, we usually mean the process of extracting resources from the surfaces of planets, like digging in the lunar soil to get metals and to get ice, or digging into asteroids. So more like what we see in mining here on the Earth, digging into the rocky materials to get the ore that we can process to make something.
Right now, a lot of focus is about the moon and about the asteroid. And just to compare the technology, when we say space mining, do you think that the moon mining, the astral mining versus the terrestrial mining, and that going to be, for sure it's going to be different, but what actually will be the difference in your view?
Okay, so the biggest problem with mining in space will be the transportation costs of going out to the moon or going to asteroids, getting the resources, and then bringing them back to the Earth. And because of the very high transportation costs, it has not been economic until recently to do mining in space. People have talked about it for, like 100 years, literally for 100 years, over 100 years, people have been talking about mining on the moon and mining in space. But only recently have the transportation costs come down low enough so that it's starting to become economically viable to access some of the resources, not all. Some of the resources in space are still not economically accessible. But I think there's a very strong argument that water on the moon is now an ore, because we have technologies that are capable of extracting the ice on the moon and capable of converting it into rocket fuel. And there is a good argument in economics that we can use that rocket fuel cheaper than we can launch the rocket fuel off the Earth. So for any activities that you want to do in space that require rocket fuel, I think it makes sense to mine the moon for ice. And I think as time goes on, as we start to do these activities off the Earth, more and more of the different resources will eventually become economic. Like once you're mining the ice on the moon, then as a byproduct, you end up with heated soil. And because you've already extracted the soil, you've put it in your processors, and it's already warm, it doesn't take as much energy to process it further to extract the metal. And so as an activity on the margin of ice mining, it becomes economic to make metal on the moon. Now, I don't think we're going to make metal in space and bring it back to the Earth for sale, not on the moon, because the metals we're typically going to make, at least in the start, will be iron and aluminum, and it's just going to be a lot cheaper to get those on the Earth. But there are things you can do with iron and aluminum and other metals in space to produce economic value back on the Earth. One example would be making gigantic antennas. We can make the structural supports for antennas that are too large to launch on a rocket. And those can provide data services to the Earth that are currently not even possible because we can't put antennas that large into orbit. And so those antennas in orbit around the Earth will provide data services to customers on the Earth. And that's an economic activity that produces revenue. So we don't actually have to bring the metal back to the Earth in order to use it economically. So I think those are some of the things that make it different in the beginning. And as time goes on, as more people are living in space and as more resources become economic, then space mining is going to start looking more and more like terrestrial mining.
Wow, I understand from what you just said, actually, the mineral is going to be used there, right? In situ, rather than bring back, because actually out there, we need so much infrastructure to actually have the settlement. And that's literally touch many topics that I want to discuss with you later. But basically, the perception people have that to digging the rare or expensive metals bring back was probably not even the first priority, right? The first priority is actually probably digging into some of the essential consumptions elements.
Yeah, I agree. I do think that in the long run, it will become economic to bring certain high value commodities back to the earth, like platinum group metals and rare earth elements. It will probably take more economic development in space before those become economically viable. So I do think in a little bit longer, just a couple of extra decades after we start mining water ice, then those other things might become economic to bring back and sell in the commodity markets here on the earth, but probably not as the first step.
Yes, I agree with you. And out of all these in space, how do you decide to very much focus on the moon? I understand that is the center of your current research and project.
Well, I actually believe that we should be focusing on the moon and asteroids. There are other people who want to put a city on Mars, and they want to live on Mars. I don't want to live on Mars, but if they want to live on Mars, I'm happy for them. And I think that their effort to try to live on Mars actually helps everything else we do in space, because they are developing the capabilities. There becomes economy of scope because of the overlap in the technologies and the overlap in the supply chain. And that economies of scope will help bring down the cost of developing the moon and asteroids. And also, people that want to settle on Mars, they become customers because they need to buy rocket fuel to go back and forth to Mars. And they need to build great big spaceships that are comfortable to live in, bigger than we would launch off the Earth. So I think it all works together. I think that Moon, Mars, and asteroids are all part of the same picture. And I really support all of the above. Now, right now, I'm mostly working on lunar technologies, but I have worked a lot on Asteroid, and I'm ready to go back and forth. I basically work on anything I have funding to work on. So if people want to give me money to work on asteroids, I'll work on asteroids.
Wow. Okay. So basically, the entire space ecosystem is so interlinked. Any development, even maybe you think that's probably not the priority, or will be further down the road, but the development on that, we're helping to develop the entire ecosystem. And I can't agree more. Yes. And you have worked on both moon and asteroid. And is that order is more like we will have a moon base in order to have a refueling center, then we can sending missions to asteroid and start mine. There is like almost kind of these kind of order, or you think that's going to happen concurrently one way or another?
I think that we're going to figure that out as we go along. And that's the nice thing about innovation, is that people try different things and then we learn what works as we do it. And so there are companies who are still working on asteroid mining. And I was having conversations with one of these companies today about asteroid mining technologies. There are other companies working on lunar resources. And so I think they're both going to be working concurrently. I think that the moon does have some benefit because we know where the moon is and it's always there. And so we know where those resources are. But asteroids also have some benefit. Now, we don't know where the small asteroids are because they're too small to see, except when they're close to the Earth. And if they're in a very similar orbit to the Earth, then they might pass us as they go around the sun, but it might be another 10 years before they pass us again. And so finding them, tracking them, and then not losing them is a challenge. But once you find the asteroids that you want to mine, the nice thing about them is they have very little gravity. So you can take the resources off of the asteroid and use it in space very, very efficiently. So I think they're complementary. I think that we will eventually be using lunar and asteroid resources in the vicinity of Earth. We call it cislunar space. Cislunar means inside the orbit of the moon. And so in this region of cislunar space, we're going to be bringing back asteroid resources. And I think it's all going to contribute to the cislunar economy.
That's good to know that actually both are interlinked, but it's not like, we have to have a moon base before we can think of asteroids. Actually, like what you said, yes, there are many companies are working on asteroids, but personally, I think probably moon will happen a bit faster. Just looking at how the process right now or what's the effort has already made in moon. That brings actually my next question. What is a technology challenging for the moon right now?
What are the most challenging technologies?
Yeah, what's the challenging technology-wise to actually, for example, I guess we're thinking of initially is like the oxygen, right? I mean, first, are we going to have manned or unmanned rigs, right? When we talk about the industrialization or moving the industry into the moon, always doing the moon mining. And then, if there is people sent there, I guess, we need to solve the oxygen and all these issues. So I don't know if that's present a technology challenging or what other technology challenging you see.
Yeah, so I think probably it'll be more economic to use robots and not have humans on the moon to do this mining and manufacturing, at least not at first. But humans are very capable, and there are additional business activities you can do on the moon if you have humans there. For example, there have been a lot of people talking about building a research park on the moon. And there are companies that want to be on the moon for whatever various reasons they have. And if those companies have a business case to be on the moon doing some kind of research, then you can support them by providing them services, provide them the research park, provide them transportation, provide them commodities, consumables, as you were mentioning. By having humans there, there's a broader business case, and you really need that broader business case to justify the expense of having the humans there. Now, personally, I have mostly focused on just the mining part. And so I mostly focus on just robots. If there are going to be humans there, the humans can troubleshoot and repair the robots a lot more efficiently, and the robots can do a lot of tasks to help the humans be more efficient. And so it will be very synergistic. But just for the sake of developing economic models, I don't want to bring in all the extra complexity of humans on the moon, so I usually just ignore that as a choice in my modeling. And so I try to model what it would be like to do the industry on the moon using only robotics. And so some of the key technologies that we need are, robots that can operate in the harsh lunar dust and the vacuum of space and low gravity and the radiation environment of space, and to do it with high reliability, and to do it without too much direct interaction from humans teleoperating. There's a 3-second time delay from the Earth out to the moon and back to the Earth again. It takes a radio wave about 3 seconds. Now, that's not much, but if you're trying to control a robot, like trying to dig in the soil, then 3 seconds is a lot. And 3 seconds can really make it difficult to operate your robot. So we need to have enough autonomy so that the robots can have just loosely supervised autonomy with the humans watching, but not controlling every little operation that they do. So I think those are some of the areas where we need advancement. But really, it's just a matter of industrial engineering. We know how to do these chemical processes. We know how to do the mining. We just have to adapt it to the lunar environment.
And in your perspective, that with the technology you just described, and where are we now? I mean, there are quite a lot of lunar companies focused on that area. And also, I think NASA and the Chinese government also putting a lot of emphasis on lunar. I mean, where are we standing in terms of technology, as, just in respect of what you said? And also, how soon you think that's going to happen?
Well, I think there's already, as you mentioned, there's already lunar programs in China, in the United States. Europe is working on collaborating with other countries. So is Japan. And I'm afraid, Korea, and I'm afraid I'm going to forget countries, United Arab Emirates, but there are countries all around the world who are working on the lunar programs. China has recently had several robotic missions to the moon. They've returned samples back to the Earth, and they're planning to start sending humans to the moon. I don't know the exact date, but I think it's within about a decade. Their plan is to graduate all the way up to having humans on the moon. NASA is also working on it. They've given a contract to SpaceX to develop a lunar lander for humans. And the schedule, I don't know exactly what it is, but also it's going to be within this decade that we should see humans from the United States on the moon. And so there are many other countries that want to do this as well. So I think this decade, we're going to be seeing an increasing number of missions, starting with robotic ones, more and more complex until eventually human missions. And by the way, this is a really good business opportunity for companies that want to develop space resources, because supporting these government-led exploration programs is a source of revenue to help the companies develop their technologies and to buy down the risk so that they can then move on to doing other activities in space after supporting the government agencies.
Absolutely. Totally agree. And that's actually one of the things you are working on, and we're going to discuss a bit further later as well. Okay. So in your view, is within this decade, definitely the lunar mining is going to take place. Am I understand correctly? Not this mission.
Well, so I don't know about other countries, what their plans are, but I can tell you a little bit that the United States talks about. And we're currently developing 2 missions that will go to the moon to study the lunar ice. And these are going to be within 2 or 3 years. And the purpose of the mission is to prospect the ice to see if we can use it as a resource to make rocket fuel. Beyond that, NASA hasn't really told any of its plans, but judging from the fact that we're going to be prospecting the resources, I'm going to guess that probably within a decade, we're going to be seeing other activities that lead all the way up to actually mining and demonstrating production of rocket fuel in space.
Wow. So the ice water in the Luna is a new oil. And probably that is going to be the first commodity will be traded in, in the space, I guess. And what do you think what kind of price are we talking about? Because I know you have been working on a lot of these kind of economics.
Yes. Well, right now, the way we judge the value of water, ice on the moon, is by how much it would cost for us to bring it from the Earth to the moon. And right now, it's going to be about $1 million per kilogram. So I don't know what the current cost of gold is, but I think that's probably more than the cost of gold. I mean, do you know?
Yeah, I mean, just the sounds of it, a kilo, yes. I need to do some calculation with ounce and all these, but it's just a lot of money. If 1 ton of water, that would be how much? That would be
a ton of water, that would be 1,000 kilograms. So that's $1 billion. Yeah, a kilogram of water would be worth $1 billion. But because the launch costs are coming down, the value of the water is also coming down, but it actually helps the economic picture because it becomes a lot easier to transport the capital to the moon in order to mine the ice and convert it into rocket fuel. So I've been working on these. I've got a paper that should be published pretty soon. And in this paper, I show the calculations for the price of water. And I believe we can make rocket fuel and bring it all the way back down to low Earth orbit and sell it in low Earth orbit for cheaper than you can launch it from the Earth. I think we can get it all the way down to less than $30, maybe even $10 per kilogram in low Earth orbit. And right now it costs about $2,000 per kilogram or $10,000 per kilogram to launch something into low Earth orbit. So I believe that lunar resources will outcompete Earth launch eventually.
100%. And I think that's the whole point in my view. But why we need to bring the water into low Earth orbit? Does that all the launch or all things need to happen from there? Or can't we just actually leave the water in the moon and shoot the mission from there?
It depends who your customers are. So there are some customers in low Earth orbit. There's another orbit called geostationary transfer orbit, and it's a very elliptical orbit. So if this is the Earth, it goes close to the Earth, but then it goes way far out, and then it comes back. So very elliptical. And when you want to put a communication satellite into geosynchronous orbit, you initially launch it into that geostationary transfer orbit, and then you have to use a rocket with thrusters to boost it to circularize that orbit into geosynchronous. And so what happens is these companies on Earth will throw a spacecraft into, we call it GTO, geostationary transfer orbit. And then you could have your booster come from the moon with rocket fuel, dock with this satellite in GTO, and then your space tug will provide the burn, the circularization burn, to put it into its final orbit. So then the customers on Earth can start to use that satellite. So that means you would want to bring the rocket fuel from the moon down to GTO in order to use it to serve your spacecraft customer. Other companies talk about having your boost services start in low Earth orbit. And that means you can launch even larger satellites on the same rocket to low Earth orbit because it costs less to put it in low Earth orbit than to put it in GTO. So it really depends where your customers are. There's going to be a mix of customers at various locations. And, when you move the rocket fuel off the moon, you're burning the rocket fuel. And so you might use 80% of the rocket fuel, bringing it from the moon down to low Earth orbit. And so you're trying to make all your profit by selling the 20% that's left over. And that's what makes it challenging. But even with that, the numbers show that it is economically viable.
Absolutely. There are so many satellites or space missions that they literally dysfunctional, not because any mechanical issue, but because they run out of fuel, right? And there's so much business around it about refueling, but actually, yes, bring from the moon where just make the economic equation is better. That's absolutely one thing. Another addition why we should get the lunar ice processed into the fuel. I remember last time you mentioned that there are quite a lot of misconception, people have when we talk about lunar mining, right? Regarding the environment and all these. And could you just elaborate a bit further on that? Because when I heard it, it was hilarious.
Yeah, so I hear this a lot, because I'm working on lunar mining. I personally really care about Earth's environment. And so I agree with the people who bring up these problems, but they just have misconceptions about it. So they're afraid that mining is going to ruin the moon, and they will say mining ruins the Earth, and they'll point to a picture of a strip mine in Australia. before they've done site remediation after they close the mine down. And they'll point to that and say, that's what we're going to do to the moon. We're going to ruin the moon. Well, first of all, they completely depend on mining in their lives. Everything we do depends on mining. And so we have to have mining to have civilization with 8 or 9 billion people living on this planet. And in order to have computers so that we can talk to each other like we're doing now, all of this depends on mining. But we can do mining in a way that remediates the environment. It minimizes the damage. But by putting it in space, we're putting it onto a planet that doesn't have biological life. It does not have sensitive ecospheres. And so it actually becomes much better if we do it, much better for the environment if we mine in space versus on the Earth. But people will also bring up these questions. They'll say, you know what? You're gonna mine the moon and take rocks off the moon, and it's going to make the moon lighter. And once the moon loses too much mass, it's going to fly away from the Earth. And then the Earth will be disrupted, and it'll cause earthquakes and tidal waves and kill everybody. But the fact is, the amount of material we're talking about mining on the moon is tiny compared to the amount of space dust that lands on the moon every year. The moon is changing its mass all the time. The Earth is losing about 40,000 tons every year because of helium and hydrogen escaping off the Earth into space. So the Earth is getting lighter. The moon is probably getting heavier. Planets don't stay the same mass, but their orbital stability doesn't depend on staying the same mass. And plus, even 40,000 tons per year is so utterly tiny compared to the mass of a planet that it's completely negligible. So these are some of the things I hear people talking about all the time. Like, you're going to ruin the moon. They're afraid they're going to look up at the moon in a telescope and they're going to see industrial sprawl, pollution and factories with smokestacks belching out smoke into the lunar atmosphere, and they're afraid it's going to look ugly. But, here's another thing, is that there are some companies that want to mine the moon, but they want to do it only underground. And there's a benefit to underground mining on the moon because you can get out of the space radiation. And so those companies want to mine the moon in a way that won't even be visible at all. It'll be completely underground.